Alright, welcome to our first exam review for this class. The idea here is I'm going to go through some of the practice questions. I do want to emphasize, please don't assume that you only need to memorize the questions that are asked. Quite frequently, in the notes and in the homework, I might have asked or I might have taught 3 or 4 different vocab terms or a couple different concepts. And on the review, I put a sample question. So number 1, for example, even though I'm asking about logical argument, most likely that's not what I'm putting on the test, but I do want you to go back and review the vocab from that particular section of the book, which should be the very first section we started at. So without further ado, let's just kind of jump in here and get started. What exactly is a logical argument? Well, I'm going to go straight to the textbook and quote it, and this is about what I would expect you to paraphrase or have some sort of idea on how to explain. So in the textbook, we read that a logical argument is a reasoned, thoughtful process using a set of facts or assumptions to support a conclusion. So I would want to see some semblance of this in your definition. All right, at number 2, we're asked to define what exactly a fallacy is. And again, I'm going to go to the textbook for this one. Fallacy is a deceptive argument in which the conclusion is not supported by the premises. In this section, we actually looked at several different types of fallacies, and actually that's the upcoming questions is to identify what the fallacies do. But the point being, a fallacy is something where we think it's a nice logical argument, but there's a deception of some type, and when you actually analyze the argument, it doesn't hold any merit or weight. So in number 3, we're asked to list the premise and conclusion of the following argument. So let's actually read it first and then decide what we're being asked to do. Now, as we're reading this, a premise is what assumptions are being made about the argument. So what is the if part? If we do this, then the then part being the conclusion. So as we're reading this statement, take a look for anything that stands out as far as what am I supposed to conclude of this, and then what evidence are they using for this conclusion, and the evidence would be what we consider to be the premise part. So here we go. Obviously, it is best not to testify on your own behalf. Casey Anthony and George Zimmerman each declined to testify, and they were both found not guilty. Okay, so after reading that, what do you think they're trying to get us to understand? What are they trying to suggest? Now, personal opinion on this. This is not real life. This is just a logic exercise. So don't take this as it. Well, my professor said, in a court of law or anything like that. All right. So what are we supposed to get out of this? And we're supposed to get, in the conclusion, is that actually the first sentence that it is best not to testify on your own behalf. That's what we're supposed to conclude from this. Now, what evidence did they provide for this? Well, they gave us two statements. They said that Casey Anthony and George Zimmerman each declined to testify. And there's actually another premise. So not only did they refuse to testify, because we're saying that testifying is not a good idea, but the other evidence is that they were both found not guilty. Okay, so the evidence, meaning the premise, the if, and we have 2 specific examples of 2 gentlemen that refused to testify, and as a consequence, they were not found guilty. And so the conclusion of this evidence is that it's best not to testify on your own behalf. Now, I don't agree with that necessarily, but again, that's not the point of the question. The point is to identify premise and conclusion. So there you go. All right, at number 4, we're asked to get more specific about these fallacies and then identify a specific fallacy given a situation. So I strongly recommend that you go back and sort of play around with these fallacies and practice identifying the different types. These are just a couple of generic statements. You're not going to see these statements on the test, but you will be asked to do the same skill or identify what fallacy they're trying to distract you with. All right, so here goes. Kate is such a horrible dresser. I don't really think should be the head of the PTA. Okay, so what's the problem with this argument? They're trying to get you to conclude that she should not be in charge of anything, but their evidence is that she's just a bad dresser. Okay, well that's actually not evidence for anything. And when you look through the different choices, the logical fallacy that they are trying to use is called personal attack. So because I don't like something about that individual, therefore they would not be qualified to do something completely else, but I'm trying to distract you with the how much I don't like this characteristic of them. Second statement reads a poster which reads, "Support the Humane Society," shows pictures of small dogs and cats in cages. Okay. Well, what's going on here? They're trying to get you to feel something. It's one of those things where you're at the checkout line and someone tries to get you to donate to a good cause. They're trying to get you to feel something, and because you felt something, therefore you're motivated to actually donate. Well, which one of these statements deal with feelings? And this is appeal to emotion. When confronted with questions from the press about alleged political scandals, a congresswoman replies that the allegations against her should be ignored because her accuser is part of the vast right-wing conspiracy. Okay, so in other words, when she gets asked about bad things she has done, she says, well, the guy asking the questions actually is a conspiracy nut. So she's trying to say, hey, don't get on my case. Look at this other person. And she's trying to distract us with something else that would be appealing. So kind of look back through these choices. Okay, and again, we've got another illustration of personal attack in that the politician is trying to say, hey, don't look at what I've done wrong. Look at the person who's asking the questions. They're the one who's done something wrong. Okay, so it's an example of personal attack. Okay, so for some reason, my software program did not like this little curvy symbol. So I'm just going to draw that in. Hopefully it showed up for you. That means not, by the way. So here we've got a truth table with P's and Q's in it, with a bunch of T's and F's. And we're just asked to fill in the blank. Okay, so not Q simply means go to all the Q column and put the opposite of it. So if Q is true, then not Q would be false. That would be true. That would be false. And that would be true. Okay. P and not Q. Okay, so the only way for a true statement to occur with an and is if both conditions, both premises are true themselves. So when they say P and not Q, I'm looking for the P column and the not Q column, and I'm looking for T's in both in order for it to be true. And if I see an F anywhere, then obviously it's a false statement. So T and F would be an F. T and T would be true. F and F would be F. And F and T would be F. Yeah, ands are very hard to get trues out of simply because they both have to be true in order for that to work. Okay, next up, P or Q. So or, now this time I just have to have one of them to have a true statement. So T or, now I'm looking at the Q column, not Q, wow. Looking at the first two columns. So if T and T, so that's a T. We have T and F, so that's a T. We have F and T, that's also a T. And F and F, which is where the false comes out. And then lastly, P or not Q. So this time I'm looking at the P column and the not Q column. And I'm looking for any T I can find. So I see one T and F, T and T, so I got one there. F and F, and F and T, so there's a T there. Okay, so there you go. Number 6, Write the negation. Lily got the highest grade on the test. Okay, with the negation, you just want to be very careful about how you negate that. It's very easy to make the opposite of other things. So it's really easy to go, Lily got the lowest grade, and think the lowest is the negation of the, and that's not actually the point. If Lily got the highest is the original statement, the negation of that is Lily did not get the highest. So we just really have to put the word not in there. And minimize the other words that we change. All right, number 7. Take the following preposition and write it into its other forms. So the converse, we switch the P and the Q statement. So the P statement, I'll kind of come right above it, is if dolphins are fish, then, if dolphins are fish, then dolphins live in water. So that's our P, that's our Q. Converse would be Q to P. So I'm just going to switch the order around. I get my mouse here. So if dolphins live in the water, then dolphins are fish. Okay. Inverse. Okay, so inverse is we take the original, so we make it a not P and a not Q. In other words, just negate the original premise and the conclusion. So if dolphins are not fish, then dolphins do not live in the water. All right, and the last piece, as far as rewriting goes, is the contrapositive. Contrapositive is, again, negation, but then we're switching the order. So here we're going to go not Q to not P. And so I just need to type out kind of what I did with the inverse, but then switch the order. So if dolphins do not live in the water, then dolphins are not fish. Okay. And then the last part asks about which statements are not logically equivalent. Well, let's kind of remind ourselves about a couple of things. The converse and inverse are logically equivalent statements. In other words, if the converse is in fact a true statement, then the inverse would also be true. Similarly, if the converse is false, then the inverse should be false. The preposition and the contrapositive are also logically equivalent statements. So if the preposition is in fact a true statement, then the contrapositive is in fact true, and again, vice versa is true as well. So if the preposition is false, then the contrapositive is false. So what's not logically equivalent? The converse is not logically equivalent to the preposition and the contrapositive. Let's see, the inverse is not logically equivalent to the preposition and the contrapositive, and the contrapositive is not logically equivalent to the converse and the inverse. So something like that. Just spell that out for me, which ones are linked together. Number 8, you're asked to create a Venn diagram to illustrate the following, and then label any relevant part. So if I have overlapping sets, what I have to remember is I've got a universal set. That's the set of everything. Overlapping simply means that there is something that the two sets have in common, and this piece is what would be considered overlapping. Disjoint sets, okay, so I've got a universal set. It's the set of everything. Disjoint sets are sets that have absolutely nothing in common, so there's no overlapping component to them. So no overlapping. Now, as far as the test is concerned, there are other cases that we've seen in this course. You do want to go back and kind of review other possible types of sets that I could toss at your general direction. All right, in number 9, we're actually given a bunch of numbers in a couple scenarios and asked to actually create a Venn diagram and then label these things. So let me start by drawing the universal set, big old box. And then let's actually read this and decide what type of picture we should draw. So in a veterinary waiting room, there are a total of 16 individuals, 8 of whom brought dogs, 5 brought cats, and 3 brought both dogs and cats. Draw a Venn diagram. Okay, so as far as classifications go, how many different types of sets do we have? Well, I've got a dog set, and I've got a cat set. Now, should the cat set overlap? Do I have people that own both types of animals? And the answer is yes. All right, so there's the cat set. Now, in the entire dog circle, I got 8 of those. And the entire cat circle, I've got 5 of those. But I want to be careful that it's not, the dog circle's got 2 pieces, and the cat circle has 2 pieces. So I want to try to figure out what's missing in my pieces. So is there something about the overlap? So do I know how many people exactly brought dogs and cats? And that would be 3. And so if I know that there are 8 dogs total, 3 of them have already been spoken for. How many have not? And that would be 5. So that piece represents that there are 5 people who own just dogs. Cats, I know there's 5 cats. 3 have already been spoken for, so that means that there are 2 that have not. So that means that there are 2 people that just brought cats. Now we can actually go one more level on this, because I know that there are 16 total, and I've only accounted for 5, 3, and 2. So I only know about 10 people, which means there's 6 people that we haven't bothered to classify. So there's 6 people that don't have a dog or a cat. Okay. Now, as far as labeling each part, that's going to be both cat and dog, just cat, just dog, and no cat or dog. And that would be perfectly fine for me. Just an indication that you understand what each number represents and how that plays a bigger part in the picture. And number 10, we're asked to identify, talk about deductive and inductive reasoning is where this section comes from. We're asked to affirm or deny the hypothesis or conclusion and to determine if it's a valid argument. I want to draw your attention to the formula chart. This is where they're getting this from. So you do get access to this formula chart on the test, and this is what I'm asking you to do, is tell me what it is, whether it's affirming or denying, and then what. And then as far as valid or true, we'll kind of go down there to bottom. So let's go back to here. Okay, so let's see if we can identify each of those statements. So the first one says, if I am sick, then I am staying home. So we're going to call the sick part P and the stay home part Q. So we have if P, then Q so far. The second statement says, I stayed home from work today. So what is that? That's actually a Q. So they're saying Q is true. So my conclusion is P is true. Now, let's kind of go back to our chart and see what that is. So if P then Q, Q is true, P is true. Okay, so what we've done is we have affirmed the conclusion. We have affirmed the conclusion. Okay, now, can we do that is the other question. In other words, if I go with the first premise that if I am sick, I stay home from work, and the second premise is that I stayed home from work, can I assume that I am therefore sick? Logically, no. I mean, we've all had times where we stayed home from work. We might have said we were sick, but we really weren't. But that's not really where it's going from. It's looking back at this chart, affirming the hypothesis is a valid conclusion and denying the conclusion is a valid. Kind of goes back to our 4 inverse, converse, contrapositive statements. The premise and the contrapositive are logically equivalent, and the converse and the inverse are logically equivalent. But you can't, just because we have a converse statement doesn't mean it's actually a true statement. So this actually is an invalid argument. So is the argument valid? Nope. Not valid.